Hi, welcome to my YouTube channel. In the previous videos, we have run several different MQA examples. In every example, we have selected a rule.index file and an .icf file. In this video, we'll introduce the structure of the rule file first. We'll start with the rule.index file. The rule.index file is actually a top file that's calling different .rule files. And here's an example. It shows the content of the rule.index file. And you can see inside this file is calling different .rule files. And each of the .rule file is actually a rule group. So the rule.index file is actually the top file calling different rule groups. Then let's go to the .rule file. This is an example of the .rule file. And in each .rule file, you can see it starts with a column and a group. And then you can find different items start with label. So each label is a new check item. And each of the check items will include a label, which is the title, and the condition, and the loops, and target, and the check functions, either check, compare, or corner. So in the rule file, it defines the items you want to check and the check conditions. Then let's go to details of each part of the rule. First of all, the common part, you can put applied model here equals binning global macro. It means this rule can be used for binning model, global model, or macro model. If you only put one binning model here, that means this rule only applies for binning model. And the group here includes a group number and the title. The group number of each of the .rule files should be different, and the group name also should be different. This group name will be shown when you use MQA GUI to select different rules. We just mentioned that each checked item starts with a label. So the label includes two parts, a label number and a label name. Inside one .rule file, the label number should be different. But there's only one case you can use same rule number when it is the same check item for NMOS and PMOS. Next one is the condition. The condition defines in what condition this rule can be used. So you can put device type here and 1 or -1 for NPMOS, and application 1 to 3 means for digital, analog, or IF. And also the other items shown in the table here. And there is a specific and a simple way to write it. You can put just the 1 here. That means this rule works for all types and all conditions. The next one is the option part. In the option part, you can also define a lot of things, like the sweep type. You can define it is DC or AC, and also you can also define the data block. If you include some data files in the QA project, the data block defines which part of the data is used for this check item. And the AT block is the same. So the data block is the curve data. The AT data will be the WAT data. And the data block can also be noise data. And here's an example, data block for the noise data and sweep type AC. And you can also use the option part to control the loops. For example, if we have 10 lanes, 10 widths, you finally have 100 different combinations. But what we want is only 10 lanes with pairs. So in this case, you can enter a data table here and provide the table name and put the file in the same directory as the rule file, this one rule file, And then inside the table, you can see different width length combinations. It's only 10 pairs of width and length, not 100. So this is what we want. Use the table to control the width length pairs. And the other way is, for example, the SASB. If you have 10 points for SA, 10 points for SB, finally you have 100 points. In most of the models we run, SA is actually equals SB. So we don't want the 100 points, we only want 10 points. So in the option part, you can use the synchro to sync SA and SB. Then in the loops part, you only need to provide the sweep for SA, and the SB will automatically synchronize to SA. So finally, you'll still only have 10 points. And then the loops part, the several different sweep types supported in the loops section. First of all, we use the length as the example. It's a log sweep. There are 10 points of L in each decade. And then the width example, the W, is a linear sweep. You define the start-stop point. And there are 3 points of width. And like the P1, P2, P3 shown here, you can also use constants. And the constants can be exact values or the VGG, VGD, and those are the constant values you define in the constant table part in the MQA GUI. And also, the sweep can be a list, like the P4 T temperature shown here. You have 3 different temperatures, T min, T norm, T max. It's a list sweep. And the next one is the target. The target defines what item you want to check. The target can be defined in the ICF file. If you already defined that target in the ICF file, you can use it directly, like the example shown here. Y equals ID set, Y equals VT-lin. That means the ID set and VT-lin already defined in the ICF file. We'll have a different session to introduce the ICF file later. And user can also define targets, use built-in functions like the cal page, cal curve, those functions. You can also redefine your target here. For example, if you have defined VT-lin in your raw file using the built-in functions, and you have another VT-lin defined in your ICF file, in this case, the final result will pick what you defined in the raw file. The target part also supports simple math calculations like plus, minus, log, those calculations. And the target part can also be a range file. In some cases, we'll want to check the parameter range. So you can actually define a range file here, put the name of the file directly here. And then inside the range file, you can see there is just a text file define different parameter names, and the warning range and error range use the comma to separate them. And the last one will be the check functions. You can use check, compare, or corner. So for different projects, different functions will be used. For the single model QA, you'll use the check or compare. Single model QA, if you don't have data, you can use check directly. If you check a model versus the data, you need to use compare. And if you are running a compare project between different models, you still need to create a compare project. And for corner QA, if you are running multiple corners from one library, and you need to use the corner function here. And for measurement QA, there's no model included. You only need the check function. And there's also some built-in functions you can use in the check or compare or corner function part. For example, the check chain 2D, compare plot, compare chain. The check chain 2D here is a check function to check the train of the model. It has two variables, the times equals 1, the INC at first equals 1. And there are two values for the times, 1 and 2. 1 stands for that curve is monotonic. 2 stands for the curve has one peak. The INC at first also have two values. -1 means the curve increases at first, and the 1 means the curve decreases at first. With the two variables and each of them has two values, we can have 4 different curves. So we can use this combination to check the train of the model. For the building functions you can use in MQA, we have listed here. First one is the check function. There are different check functions you can use. And the plot function, you have also different functions to create different kinds of plots. And the calculation function, you can use it to calculate different readouts. For the complex number functions, if you are doing RF model, you will need to use it for the model check. Okay, that's the syntax for the MQA rules part. I will also create some examples to show you how to modify those rules later. Thank you.